Same thing maybe goes for user 2. Oh, indeed, we have the user details as well as the flag. Welcome to this new video in which I'm going to show you how I solved the Von Lawyer's bug bounty-like challenge. If you recall from a previous video, I've covered this awesome platform made available by Adam, who has a Twitter account which you can follow, and we've covered the first challenge. We'll begin. It had 9 flags, so I reached out to Adam and asked him if it was possible for me to cover another challenge, and he was okay with that. So in this video we're going to see a walkthrough of my methodology behind solving this challenge. So let's get started. If you are new to the Hackerish channel, it explains various concepts and includes tutorials about ethical hacking. Hopefully you will find something interesting for you. You have bug bounty tips, hack for fun and profit podcast, OWASP top 10 training, live hacking sessions, etc. There's also a blog. Visit and read various ethical hacking content. Let's talk about the goal of this challenge. Let's hit begin. From what I understood, it's about a law firm that we need to hack in order to remove a case. Obviously, we wouldn't do that in real life, but because this is just a CTF, it's ethical. Otherwise, it would be unethical and you would be a black hat. The first thing we need to note is the special CTF challenge cookie that we need to integrate in all our HTTP requests if we want the server to honor our calls. Otherwise, you would get an error. The second thing is these are the word lists that can be used when you want to solve a challenge in that platform. I have already covered those in a previous video about this platform. To keep things organized, I'm going to create 2 folders, word lists and Von Lawyers under CTF challenge under hacking directory. And then I'm going to cd into hacking CTF challenge and the word list directory to download these word lists using wget. And now I have all the files here. Let's now cd into our Von Lawyers directory. And the first thing we notice is that the top level domain is vonlawyers.co.uk. So the first exercise we're going to do is enumerate subdomains. To do that, I'm going to use DNS recon. I'm going to clone the directory. I'm going to use pip3 to install the requirements. And then we can access the help by just running the dnsrecon.py file without any options. So from here, we know that we want to use the -d lowercase with our domain, and then -d for the dictionary, capital case. And then we want to specify the type to be brute force. So here we will use the vonlawyers.co.uk top level domain. And then for the word lists, I'm going to use the word lists.names.txt. And I need the type like this. After a couple of minutes, we find that we effectively have the www subdomain, but we also have the data subdomain. And that was possible because we had the name data inside our word list. So if I do a grep on the word data in our names file word list, we can see that we indeed have an entry for data. All right, so let's document this in our file. So for subdomains, we have www and then data. So the next step is to enumerate what services are running on each one of those. I already have a Kali Linux container, which I can run using docker start and the ID of my container, and then docker exec-it, my container ID, and then bash. I'm going to run nmap. I'm interested in open ports with top 100 ports. And then I want verbose option to spot ports as they appear. Nmap is not installed, so I'm going to install it. Now I'm going to rerun my previous command. Alright, it seems that we have two open ports, 22 for SSH and 80 for web server. Let's do the same thing for data. And it seems that we have the same open ports. Now notice that both of them resolve to the same IP address, which means that these are hosted on various directories and there's some kind of routing between the subdomains. So let's document this. All right, let's start with the www.subdomain. And the next step after doing port scanning is directory enumeration. But before that, let's just visit the web page, since this is a web server, on port 80 and see what we can find. And as you can see, it has only a h1 tag and maybe h2 or h3 with an image. Let's right click and view the page source. I don't see anything suspicious. We have a CSS file for Bootstrap and we have jQuery and the JavaScript for Bootstrap. So the idea now is to just go ahead and use FUF with our word list. First of all, I'm going to install Golang. Now, if I run Go, I have the help menu. So now what we can do is go get, and the repository name is FUF under the FUF user or organization. I guess we don't need the HTTPS. All right, so it says that Git is not installed. Let's install it. It's just a fresh Kali Linux without any tools installed in it. So like Nmap, I used apt, so here we are going to install Git. We're using the yes option to avoid the yes prompt. All right, let's try once more without the HTTPS scheme, and it seems that our command has run successfully. You can see that with the exit code 0. Now we still have command not found, and that's normal because we don't have that in the path. So if we go to the home directory of the current user, in this case it's the root user, we should find the Go folder, which normally hosts the binaries of our installed tools as well as the source code. And here you can see that we have the FUF script. So what we can do is add this to our path. So let's edit our bash rc file, if I could type. And let's just add this at the bottom by assigning the path variable with the current variable value, and then by adding the path to the binary folder for our Go directory. And then we can just save that file and then source it. And now we have FUF working as expected. So what I can do is just copy my word list directory to Kali. So I can do that using docker copy. Let's do copy just like that. Now, if I exec into my Docker container and then list what we have in my word list directory, we can find our word lists. We will use the word list that is under word lists and then common, which contains the interesting directories that we can use during our directory enumeration phase. And then we specify the URL. In this case, that would be http://lawyers.co.uk. Then we're going to specify placeholder by using the keyword fuzz. Once we hit OK or enter, we have right away some results, in this case CSS, images, and JavaScript, which are common directories found in many web servers. As you can see, we don't find anything interesting, and that's normal because we need to add our cookie related to the current user, which is connected to CTF challenges. So when you go to challenges, fallen lawyers, you have this CTF challenge that we need to add as part of the cookie header. And now when we run it again, we find an interesting directory called logging. If if we go to that directory, we see a response access denied from your IP address. And I guess that's again due to the fact that our cookie is not present. Let's verify that. Nope, it seems that the cookie is sent correctly. Let's do the same thing, directory enumeration for the data subdomain and see what we get. Interesting. We have a users endpoint. So let's try to access it. It seems that it returns a list of users with a flag here. So here we have the first flag and a list of users. Let's copy them and put them in our notes. So that would be for the data subdomain. And we've accessed this using /users. Now, going back to our logging, we see that it doesn't work. So let's try to mess up with the requests using burpsuit. All right, so it seems that this is our request /logging, and the response returns a access denied can be found with a flag. So when we go to logging, we have this flag. When you inspect the response, we have something that doesn't show up in the HTML page on the browser, and that's pointing to /lawyers only. So let's copy that and see what we get. All right, so now we're talking. We land on a login portal and we already have a list of emails. So potentially one of them would be a valid email to log in, but we don't have passwords. So we need to brute force those. So first of all, I'm going to send a test request to record it in burp. So that would be this post request, which sends a request to lawyers only logging with our post data, email, and password. I'm going to use intruder and I'm going to select email and password. For the attack type, I'm going to use cluster bomb. The name of those attacks is a bit weird, but you can find detail for each one of them here by clicking on this question mark. Cluster bomb uses something like a iteration over the second position of our payload. So in this case, if there are two payload positions, the attack will place the first payload from payload set 2 into position 2 and iterate through all the payloads in set 1, position 1, and then place the second payload from payload set 2 into position 2 and iterate through all the payloads in set 1 in position 1. And that basically means that we're going to use a spraying attack because we are going to use passwords and iterate through usernames. So as you can see, the second payload here is our password. I'm going to choose password 1 from a list and then iterate through all the emails, and this will potentially avoid any account locking put in place. As of the payloads, I'm going to use the ones I've downloaded from CTF Challenge website. I'm going to copy that and paste it in my second set. And for the usernames, I'm going to get the list of emails from what we found earlier. So these are the emails. Now I'm very lazy, I don't want to copy them manually, so I'm going to just use bash and grun to basically extract them. So first of all, I'm going to install grun, which is also another tool written by TumNumNum, and I'm going to fetch the data subdomain. Using the user's endpoint, I'm going to use my cookie from CTF Challenge. Hilarious. Curl is not installed. Okay, let's install it real quick and rerun our previous request. Okay, so we have our results. So I'm going to pipe that into grun, and now we have a list of parsed JSON results. I'm going to grep for email. Now I have just a list of emails, and then I'm going to cut based on the double quote separator and then use the second field. And just like that, I have a list of emails. So let's copy them and paste them in intruder, payload set 1. So I think that we are good to go. I'm just going to decode to uncheck the URL encode option, and let's start the attack. So as you can see, we start with password 123456, and then we iterate through all the emails. Same thing for password, etc., etc. Now, obviously, we have 401, which means unauthorized request. But if we sort by status column, we have one request which redirects to something based on the response code 302, which means redirect. It seems that we have a valid username and password for this email with the password summer. Let's record that. So that's under lawyers only. And we have the email and the password, which is summer. Always use strong passwords. You can check my video about a comparison of the various approaches to using strong passwords. So let's use the email and password summer, and we get access to the portal. Nice. Okay, so we've recorded the flag. However, we don't have the possibility to edit that case. The objective, if you remember, is to remove that case, to delete it. If we go to profile, we see that we can update the user details. Once we hit update button, it seems that the feature is not enabled. Let's see if we can inspect the source code for that page. If we go back to the proxy, when we send the request logging, we get redirected with a token to /lawyers only. And this is the dashboard after the logging. As you can see, we have the same flag that we saw in our web browser. But when we go to lawyers only profile, we see a call to /lawyers only profile -details/4. So it seems that it fetches the email and the name and then prints them in the screen. No, it doesn't print them. It just gets their values, and that's it. So it seems that this is an unfinished code that got shipped into production without control. So this is kind of a leak of an endpoint, which is interesting. And as you can see here, later on, we have a call to that same endpoint, which surprisingly returns the password in plain text. All right, so that's interesting. Now, if we send this to the repeater and play with the request and specifically change the ID of that user, now if we send that, look at that. We get the password for the user Yusuf in plain text. So although this is a really strong password, we were able to extract it using an IDOR vulnerability. Same thing maybe goes for user 2. Oh, indeed, we have the user details as well as the flag. Let's document this. I suspect that because we have a flag entry here for that user, I think that this is the user that we can use in our next logging and see if we have the privileges to remove the case. So let's log out and then log back in using our new user and the password blah blah blah. And indeed, we have access to the same portal, but in this case, using Shine, we can potentially delete that case. So let's see if we can do that. Click, and at last we have the final flag. We have reached our objective. All right, so we have 1, 2, 3, 4, 5 flags, and here we need 6 flags. The 6th one can be found under the root directory of the data subdomain. So under the root directory, we have our flag, our 6th flag. So as you can see, we were able to delete a case and reach our objective by doing subdomain enumeration, port scanning, directory enumeration, some JavaScript analysis, and exploiting an IDOR vulnerability with an information disclosure of the password in plain text. Combining all this together, we were able to delete the law firm's case and reach our objective. If you found this content helpful, make sure to like, comment, and subscribe to this channel so that you get updates whenever I publish a new video on ethical hacking and bug bounty hunting. If you're new to hacking and want to learn the basics, check out the free OWASP Top 10 theory and hands-on training on thehackerish.com and apply your knowledge on the lab which supports it. If you enjoy learning with videos, I invite you to watch the OWASP Top 10 YouTube playlist. However, I encourage you to first try to solve the lab exercises so that you don't spoil them. Don't forget that there are supporting blog posts for most of the videos you watch on this YouTube channel. I also encourage you to subscribe to the Friday newsletter on thehackerish.com to gain some new hacking knowledge at the end of the week. If you enjoy listening while doing other things at the same time, check out the Hack for Fun and Profit podcast, link in the description box. Until next time, stay curious, keep learning, and go find some bugs.